welcome. I am going to be opening this platinum surprise box. So here we go. I wonder what this is. Coils, slider, relay, crystal chips, multiplexer, LED, transistors, flip-flop, dead bug.
Cheese.
It's raining
Circuits.
raining
Circuits.
raining
Circuits.
it's raining
Circuits. Okay, we're thinning out the herd here. Just like my hairline. I never need any of these logic chips. So I'm thinking maybe I'll make a challenge myself to make a project with whatever's in the box, you know? See what we can do. Maybe I can make a reaction time test or something, I don't know. Oh, there's a bug on the edge of the screen. Whoa, like an edge bug. I can make a thing that you press it and it cycles through somehow a bunch of options. What if I could do something that rolls a dice? That would be cool. Ooh, what about yeah. How about a random number generator that just gives you a random number on one of these? That'd be kind of cool. It can just do some sort of loop where it charges and discharges quickly. And based on when you press it, it just reads the number at that point. That could work. We don't even have any resistors, unless these are resistors. That could be, this is gonna look so funny. These are resistors. And this will help me get different values for each one. So I just need to reinvent the 555 timer. Build your own 555 timer. Okay. Oh no. No. So I can do maybe an oscillator. Okay. I'll draw out the full thing now. Oh, I'm dumb. I wrote these off, but these are gonna save my life here. All right, 5-volt ground. Yeah, look at that. You can change the brightness. Oops, I may have burnt out the LED by changing the dial too far. Yep, you can see the burn marks on it. That's what I'm talking about. I don't want to risk it for the biscuit. I just killed one of my components. I definitely smell the magic smoke smell. So it should be oscillating 3 times a second, but it's oscillating 3 times a year. I don't know, not really, but it's much slower. I'm gonna call it here for today. I'll pick it up tomorrow. The plan is to just break the circuit apart in half, do 1/2 at a time. So I found a better circuit, but first I want to try out this one with some better capacitors. So apparently the capacitors are 1 million times too big. Yeah, here we go. Learningabout.electronics.com. Look at this, 12-volt line. Oh, look at that! We have an oscillator. Are you seeing this? That is so cool. That is so sick. There we go. And now let's zoom out. Oh, look at that. That is so cool. Even if I just made a blinky light, I love it. Now what happens if we add another capacitor? Would it be half as fast, basically? Yeah, it's slowed down. Now, we gotta see if that can enter the flip-flop. Yeah, I made an oscillator, but it doesn't go loud enough. But only when it's plugged in. Maybe I need to amplify the signal. That'd be interesting. Maybe I need a resistor so it doesn't modify it so much. I have no idea. Try it. Maybe I need a pull up resistor. No, pull down. I mean, it's not floating, so I don't know. Oh, it worked! It worked! I needed a pull down resistor. Oh, but look at this. I put the clock low and it stops. I'm trying to catch it when it's high. Oh, that's why it's so hard to catch it. Such a narrow window. So if I can make that signal longer, then it will latch. All right, we need to get wide. Oh, we've got a constant rate on off. Well, ish. Look at that. That is awesome. And it's 1, 2, 3, 4, 5 capacitors. Gives us 200 microfarad if it started at 1,000. That is so satisfying, and that's digital. So that means I can latch it. Oh, I can latch it on the on or off state. And that means we can have 4 of these for a 4-bit situation. Do we have enough for? We might only have enough for 3. Yeah, we have exactly enough for 3 of these. And I just dropped one. That makes the other circuit simpler, actually, because of our demux thing. We'll have 3 inputs and only 8 outputs, so it'll just be a number between 0 and 7, or 1 and 8, whatever we want. This is so cool. So we've got an oscillator, an amplifier that goes into a capacitor. The output of the amplifier goes into a capacitor. The output of that goes into a digital latch. Then we'll have a button that stops the latch. And then we'll have 3 of these entire circuits. And then the 3 bits go into a selector, selects 1 of 8. And then each of those triggers a different number through diodes, which I don't know if we actually can do. Oh, we can use LEDs as diodes as well. I don't think we have enough. Oh, we do. We have a bunch of these. I just have to take them apart. Am I doing this right? Yeah, we can use LEDs as diodes. Let's add the next chip. So you press it and boom, stops the clock. That's so cool. This is gonna be awesome. I didn't think I could make something even this good with all this crap in the box. I'm gonna do some fun components. All right, check out the progress on this random number generator circuit. These potentiometers are here because I don't have any normal resistors. And there's a lot of roadblocks to get to this point. This is sick. I haven't done this in a while. I'll just make a circuit. There's a lot of cleanup to do. I'll clean up when I finish the project. All right, bye. Hello. Boom. It's day 3 of a quick 1-day project, as usual, as things go.
Classic project timetable.
Yep. From this mystery box of components, I have created a 3-part circuit. Or maybe 4-part? I don't know. Once it's digital, that's easy compared to all of this. Then I had to tune these resistor values, but now that it's all digital, there's no resistors needed. So, I'm fairly confident it's gonna work, so I'll just make this circuit permanent. And hope I don't mess it up. So I anticipate soldering it up, and then it's not gonna work, and I have to debug it. I'll try and test it along the way as much as I can, but you know how it goes. So we've got our A, B, and C input, and then we've got our 1, 2, 3, 4, 5, 6, 7, 8. We count up in binary. And so then this one would be 1, 1. That's our output of our multiplexer chip. Then we want our 7-segment to do certain things based on that. For number 1, we're gonna want B and C to be on. And the rest will be 0. Then for 2, A, B, G, E, D. And then for 3, everything except for F and E. For 4, F, G, B, and C. For 5, everything except for B and E. For 6, everything except for B. And then for 7, A, B, C. For 8, it's all of them. button should be the only thing left, so let's test it. And it's not working now. I mean, it's generating this randomness here, but here is supposed to be a number. I might have to stop for today. I was hoping it would just work, but you know, try a few things. You know what? I did what I said I would do today. I soldered it, but now tomorrow we'll be debugging it. Didn't expect that to happen, although I should have. So I'm fairly confident it's gonna work, so I'll just make this circuit permanent and hope I don't mess it up. No such luck. I will debug tomorrow. So they say that in theory and practice are the same thing. In practice, they're different. In theory, this should work, but in practice, it's not doing that. It's time to debug and hopefully finish this up tonight. Oh, there's a missing connection. See, this is the problem. I went too long last time and I got tired. And I was like making mistakes left and right. 6 minutes in, I found a bug already. Debugging is going great. Okay, I think that's fixed. We got some back propagation. 3 turns on all of them. What if I disconnect 3? So the chip is not behaving like I would expect. We can do it manually. Oh, the clock only applies to 2 of them. So I need to connect the clocks. That's it. That explains a lot. There's 2 separate clock lines for some reason. Okay, that should be the last thing. Okay, moment of truth part 7. Lucky number 7. Never mind that I just randomly started counting at 5 at some point. There's been about 5 tests. Okay, we rolled an 8. We rolled a 7. It's working! Woo! Let's go. We rolled a 4. That's it. It only took less than an hour to debug. I should have stopped way earlier yesterday because I started making so many mistakes and everything, but also I did need to just come back to it and see it fresh. So this is all through components from here. And look at that. It's so poetic. The circuit will go back in the box. From the box it came into the box it will return. No, it doesn't fit. What a fitting end. An unfitting fitting end. Alright, still a bit tall on this side. Alright, it fits, it fits. Boom. So, the circuit made from mystery components is finally done. Turn it on. It randomly goes through all the numbers, and then you hit the button, and it stops. So it's rolling an 8-sided dice. And there we rolled a 4. Let's see if we can roll an 8. Oh, we rolled a 1. Anyway, it's been super fun. So now it's just cleanup. I didn't expect to get it working today. I really thought I had messed something up in an unrecoverable way. I thought it would take much longer and be much less successful. That's great. Ooh.